Assalamu alaikum. Welcome, dear students, to our first part in Chapter 16, Force and Interaction. By the end of this chapter, you will be able to recognize the effects of a force, indicate the characteristics of a force, classify the forces into contact and non-contact forces, and determine graphically the resultant of two forces. We have studied in grade 8 as well as in grade 9 that a force, push or pull, is a mechanical action exerted by one object on another. But a force is not seen. We actually know that it exists by its effects. So what are the effects of a force? Let's watch the following video, which helps you in remembering the effects of a force. You can take some remarks during your watch. Then, a force may set a body in motion. It may modify the motion of a moving body by changing its direction, speed, or by stopping the motion, and it can deform the shape of a body. After we have defined a force and listed its effects, we need to review the types of forces. Remember that we've classified forces into two groups, contact and non-contact forces, which we call forces acting from a distance. So what is the difference between these two groups, and what are some examples of particular forces in each group? Contact forces are forces which results from the interaction of two objects in contact with each other, such as muscular force applied by a part of a body on an object in contact with it. Friction force, which acts on objects in motion or on objects which tends to move. Such force opposes the direction of motion of the object. Such force is applied by rough surfaces on moving objects. A type of friction is the air resistance, which is a friction between air and another material. Another contact force is the normal force exerted by supports on objects in contact with them. Also, we have the tension force exerted by springs, ropes, chains, etc. Now let's move to the non-contact forces, those acting from a distance. The most important force is the gravitational force, weight, exerted by the gravity of Earth on all objects. This force pulls all the objects toward the center of Earth with a magnitude of mg. Another force is the magnetic force applied by a magnet on another magnet or on metallic objects. Also, we have the electric force, which is an interaction between two objects where at least one of them is charged. The electric force could be a repulsive or an attractive force, depending on the charges carried by the two objects, where like charges repel and unlike charges attract each other. Different forces may have the same effect, so how can we distinguish between them? Also, what is the way used to represent a force? Each force is characterized by four characteristics which are all presented in a vector. A force has a point of application, which is the point where the force is applied. It is drawn along a specific line of action, which could be horizontal, vertical, or oblique, making a certain angle alpha with either the horizontal or the vertical. Each force is also applied in a specific direction, to the right, to the left, upward, or downward. And don't forget that each force has a different strength, which we usually express as a numerical value expressed in Newton. This is the magnitude of a force, which could be measured using a spring balance or dynamometer. All these characteristics are presented in a vector. That's why a force is a vector quantity. Now let's practice by solving application 1. Don't forget to pause the video and try to solve the applications by yourself. Represent to the scale each 1 cm 50 Newton on the adjacent figure the two horizontal pushing forces of the lower and upper hand whose magnitudes are 100 Newton and 15 Newton respectively, as well as the pulling force of magnitude 200 Newton. It's clear from the figure that the three forces are applied along a horizontal line and directed to the right. We still need to know the length of each vector, then we draw it using a ruler. To indicate the length of each vector, we use the scale. Each 1 cm corresponds to 50 Newton. From the given, the upper hand is of magnitude, the force exerted by the upper hand is of magnitude 15 Newton. Then 50 Newton corresponds to 1 cm. Then we draw F1 directed to the right of length 1 cm. Now, F2 is of magnitude 100 Newton. Then applying the cross multiplication method, each 1 cm corresponds to 50 Newton. Then the length of F2, whose magnitude is 100 Newton, is equal to 100 divided by 50, which gives us 2 cm. Now, using a ruler, we draw the second force F2 exerted by the lower hand of length 2 cm. Similarly, F3 is of length 4 cm, and also using a ruler we draw F3 of length 4 cm. Now when it comes to represent the group of external forces acting on a body, we say we are drawing the free body diagram of this body. To draw the free body diagram, we first choose the system under study, then we list all the external forces acting on this system. After that, we represent these forces by vectors on the figure. The drawing could be to a scale or not to a scale. Now let's practice on the free body diagram using application 2. Also try to solve the application by yourself. You have this figure, you have this box which is the system S, and you are asked to name and represent not to a scale the external forces acting on S. We start by indicating the system, which is the block S. Then we need to list all the external forces acting on S and represent them without considering a scale. We start with the pushing force F exerted by the hands of the man on the block S. This force is drawn along an oblique line directed upward to the right. Also, we have the gravitational force or weight exerted by Earth, which is always applied in the center of gravity of S along a vertical line and directed downward. In this way, the center of gravity is the intersection of the diagonals of the block. So this is the center of gravity. We have also the normal reaction and vector, which is drawn along a line perpendicular to the support from the center of contact between the support and the system S. And this is the normal force. Also, we have the friction force, which opposes the direction of motion of the block S. So we draw it from the center of contact between the support and directed opposite to the direction of motion and drawn along the support itself. This is the friction force F. Let's have another application 3. You are asked to name and represent not to a scale the external forces acting on B. From the figure, B is this block. Then the system is the block B. The external forces acting on B are the weight or gravitational force exerted by Earth, which is always drawn from the center of gravity along a vertical line and directed downward. Also, we have the tension force, I will call it T1, exerted by this spring on the block B. B is also attached to another spring or cable. This cable exerts another tension force, I will call it T2, on the block B, where this force is applied in the point of contact between this cable and B and directed downward. Now the same question is repeated, but this time the external forces are on the sphere S and not on the block B. Then, after indicating the system, which is the sphere S, we need to list all the external forces acting on S. We start by the weight of S, which is the force exerted by Earth on S. We will call it W prime to distinguish between it and the weight of B. We will represent it vertically downward from the center of gravity of S in this way. Also, the cable where S is attached to exerts a tension force. I will call it T prime 2, which is directed from the figure vertically upward. Now let's summarize the ideas of this video. We have studied the effects of a force, which are to set a body in motion, to modify the motion of an object by changing its direction, speed, or by stopping it, also to deform the shape of a body. We have also classified forces into two groups, contact forces and non-contact forces, which are forces acting from a distance. And finally, we have listed the characteristics of the force, which is a vector quantity. These characteristics are the point of application, the line of action, the direction, and the magnitude. This is the end of part 1. Thanks for your attention.